Hello, and welcome to the next installment in our Pre-Calculus 30 course. Today we are going to look at arc length and the unit circle. So, in order to figure out the arc length of a circle, there are a couple things we need to understand. Let's start by looking at these two circles. Now here I have two concentric circles. Concentric meaning they share the same center. So this larger outer circle and the smaller inner circle, they have a common center right here. So they're concentric. Now, the smaller circle I've designated to have a radius of exactly 1. The larger circle goes a little bit further out, and I'm going to say it's exactly twice as far out, and I'm going to note there that the radius of the larger circle is 2. Now I've set up this angle so that this is 1 radian. Now from yesterday's lesson, we learned that if the radius of this smaller circle is exactly 1, and the central angle here for this circle is exactly 1, that means this arc length from this point to this point along the edge of this smaller circle must be, what's your guess? Oh no, you're way off. Oh, sorry, you said 1? Okay, I thought I heard 17, but okay, 1 is actually correct. Good job. So the arc length here is 1. And now, even though these two concentric circles share this identical central angle, and they share this radius and this radius, the outer circle has a longer radius. And if you consider the arcs at the edges of each of these circles, well, we just calculated that this one has an arc length of exactly 1. But what about this one? It's obviously bigger than the arc length of the smaller circle. And so here the radius is 2, and the central angle is still 1 radian. As it turns out, this arc length is exactly 2. Now, if we add another radian into our circle that I have down here, another 1 radian angle, let's take a look at our arc lengths now. I'll clean this up a little bit for us. So get rid of all this. Now we know that this angle from here to here is now 2 radians because we have just added a second. And this radius we haven't changed at all. So this is still 1. And again, the radius for the larger circle is still 2. So now we're looking at this arc length for the smaller circle that goes from here around to here. We knew that when we only had a 1 radian measure, we took our 1, we multiplied it by 1 radian, and we had an arc length of 1. But now we've doubled that. So in this case, we now will have an arc length of 2. But what about this bigger circle? It has a radius of 2, and now the central angle is 2 full radians. So we take our central angle in radians and we multiply it by our radius, and that will give us the arc length that goes from here to here along the outside of this larger circle. So in this case, our arc length will be 4. There it is. Okay. So our arc length is 4. So what have we learned? When we had a radius of 1 and our angle was 1 radian, we had an arc length of exactly 1, the exact same length of the radius. Now, when our radius was 2, we took 2 and we multiplied it by our angle in radians, and we ended up with our arc length of 2. So we move further on. If our radius is 1 and our angle is 2 radians, now we multiply these two again and we get a larger arc length. And we can keep going. A radius of 2 and an angle of 2 radians will give us an arc length of 4. So take a second, pause the video, see if you can fill out the last two squares right here, and then start up the video and I'll go through the answer with you. Okay, welcome back. I'm sure you did a great job with this, so we'll breeze through it quickly. If our radius is 1 and we have an angle of 3 radians, we multiply these two together and we will have an arc length of 3. Now, if our radius is exactly twice as large through the same angle, then our arc length will be also exactly twice as large. And again, you can find this value just by multiplying the radius times the arc length. So we do have a general form of the equation between relating radius and angle and arc length, and that equation is A, the arc length, is equal to the angle in radians times the radius. Now it's important that this angle is in radians, because if it's in degrees it will give us a completely out to lunch value. So let's take a look at an example here. This is on page 173 of your Pre-Calculus 12 textbook, and we are determining the arc length. So a student is taking a course in industrial engineering, and she is designing the interface of a DVD player. Now, she wants to include this decorative arc in front of the power button. Now, I didn't make such a nice, smooth, perfectly semicircular arc because the software didn't really allow for me to do that, but let's just pretend that it is. So we have a central angle of 130 degrees. Now, this is the biggest thing to note here, is that this angle has been given to us in degrees. So the first thing we're going to need to do in order to find this arc length is convert this degree angle into radians. So we can use this formula. Alright, so we start with 130 degrees. Now, 130 degrees relates to 180 degrees in the same way that our unknown value x relates to pi. So we do our multiplication, 130 times pi, which is 3.14, and then divide the result by 180, and we end up with 2.27 radians. So x equals 2.27. And x, of course, this is our theta, our angle, our central angle in radians. So now we can use this formula. So we can say we want to calculate the arc length, and this is the information that we're given. We now have this expressed in radians. So arc length is 2.27 radians multiplied by the radius, which is 6.7 millimeters. And we end up with an arc length of, multiply by 6.7, and we get 15.19. And this unit will be in millimeters. Okay, so I hope that was reasonably clear. Now I want you to pause the video and complete the your turn at the bottom of page 174, and then when you're done you can come back and check out the answers for the your turn. Alright, welcome back. Here are the answers for the your turn. The first one, A, the arc length will be 11.39 centimeters. B, the radius will be 2.61 millimeters. And C, the angle will be 2.6 radians. So if you didn't come up with these answers, go back, give it another try, see if you can manipulate this formula to isolate the variable that you're looking for in each one of these cases. Alright, so let's take a look at the unit circle now. I've included a couple common triangles over here. This is the 30-60 triangle, and this is the 45-45 triangle. So I've indicated that the hypotenuse for each of these triangles is 1, and shown what the resulting legs would be based on these angles. Now the reason I indicated these as 1 is that when we look at the unit circle, the reason it's called unit is that each one of these radii from the center to the edge of the circle will have exactly 1 as its length. Now, what are these angles? The unit circle includes the most common angles here. So, for example, this angle is 90 degrees. This angle is 180 degrees. This is 30 degrees. This is 45 degrees. And this is 60 degrees. Now you can keep adding 30 and then add 45 to 90 to get this one, and so on all around this circle to figure out exactly what these angles are. But we're not here to focus too much on the angles. And we already know how to convert these angles into radians, so I guess my challenge to you is to do that conversion on your own time, and then you can write down the angles in both degrees and radians. What we are going to focus on is the actual values of these points, the coordinates of each one of these points at the ends of, or at the edge of this circle. So we know that each one of these has a length of 1. And these common angles, this inside angle right here is 30 degrees. So since every radius here has a value of 1, we know that this point will have x equals 1 because we go from the center to the edge in the x direction, and a y value of 0 because we're not going up or down at all, we're going straight over from the origin. Similarly, this point right here, we are only going up and we are not moving left or right. So since we're not moving left or right, it will have a value of 0, and since we moved 1 up, it will have a y value of 1. And then over here, we will have, since we moved left in the x direction, it will be a negative value, and the y direction, again, we haven't moved up or down from the center, so the y gets a value of 0. And finally down here, we haven't moved left or right, so x gets a value of 0, but we have moved up or down, and y will get a value of 1. Okay, now we want to figure out the coordinates of the end points of all these other angles. So we have 3 here, 3 here, 3 here, and 3 down here. Now we know in this direction, for the bottom half of this entire circle, all the y values will be negative, all the y coordinates. And in the top half of the circle, all the y values will be positive. On the right side, all the x values will be positive, and on the left side, all the x values will be negative. So let's first take a look at this point right here. Now, this angle is 30 degrees, which is also pi over 6, and we know that this value is 1. If we drop this straight down from this point, this will make a 90-degree angle with our x-axis. Now, since this is 90, we can refer to our triangle over here. We would know that this distance from the x-axis up to this point is exactly 1/2. And this distance from the center of the circle out to this point in the x direction is exactly √3/2. So this point has the x coordinate from the center over to here of √3/2, and it has the y coordinate from the x-axis upwards of 1/2. So let's move on. The next angle we'll look at is this one right here that goes to the 45. So the 45, we know again that this radius is 1, so that would be analogous to the hypotenuse in this triangle over here. That means that if we drop this down and make this a 90, this is 45 and this is 45, meaning that the length from here to here will be identical to this, which is root 2 over 2. Now this is in the x direction, root 2 over 2. And in the y direction, from the x-axis up to this point, right here, is also root 2 over 2. So that's the coordinates of those points at 45 degrees. Now let's move on to 60 degrees, and then I'll probably let you take it away to complete the rest of the circle on your own. So 60 degrees, now all we would really have to do is take this, and we already have a 30-60 triangle, so all we'd have to do is flip it, and here I'll flip it the other way so it looks, oh, that's not what I wanted. Okay, there we go. And now my numbers are all messed up. So this is a 60. It would go right in here. And this length right here, again, is 1. And now the height, if we drop this down, this is 90. And the height from here all the way up to here is analogous to this length right here. And now my numbers are all messed up, but this used to say root 3 over 2. So that's the height, that would be the y coordinate, so it comes second, root 3 over 2. And the length from the center of the circle out to this point in this direction, so this length here or here, is exactly 1/2. So that would be the x coordinate. Now you'll notice that 30 and 60, they share a triangle. Now in the 30 degree here we had root 3 over 2 and 1/2, and now the 60, all we've done is take these and we've flipped them. So now our x value is 1/2 and our y value is root 3 over 2, whereas before it was the other way around. Now I'll get you started on how to complete the rest of the circle, and then I'll let you go off and do it on your own. So right here we would have 60 degrees in this sort of central angle from here to here. This would be the equivalent of our 60 in this quadrant. Now if this is 60, we can drop this down, and you'll notice that now we're moving from the center of the circle to the left, which will mean we will have a negative x value for our coordinate up here. It will be the same as the other 60 over here, except that we're going in the negative direction now. So instead of 1/2, we will have negative 1/2. But what about the y? We're still going from the x-axis in an upwards direction, so y is still positive. So this will be positive root 3 over 2 for the y. So you'll notice in this quadrant, all the x values will now have a negative value, and the y values will stay positive. Everything else will stay the same, so this will be negative root 2 over 2, and then the y value will be positive root 2 over 2, and so on for this one over here. Now once you get below this half of the circle, over here, our x is negative and our y is negative. So we'll have all the same values, except they will all be negative instead. So for example, this one will be negative root 3 over 2 and negative 1/2. And then over here, the x is positive because we're moving in the positive x direction, and the y's will all be negative, but again, they will have the same values as their counterparts on the other half of the circle. Okay, so give it a try, see if you can do it. I'll see you in class tomorrow, and I'll look over your unit circles and see if you've completed them properly. Or you can just go on to Google and cheat but you know, you're not going to learn as much that way. So have a good night. See you tomorrow.